Hello friends, in the previous class we are discussing about the different formulas which can be used for sample size determination. Now, in this class we will take a look or we will try to calculate the sample size by using those particular formula. So, as I told, the most of the formula which are used for the sample size determination, that are the based on the Cochrane formula or derivation of the Cochrane formula. Later stages different researchers they modify the formula. The basic idea was of Cochrane. So, the Cochrane formula, the first formula. So, for calculating sample size, Cochrane have two different formula, for one for the categorical or continuous variable, another for the categorical variable. Continuous variable or sometimes we call the scale variable. So, in case of the scale variable, okay, three important for determining sample size, three aspect is there. One is the you have to calculate or you have to look into the level of significance, means the chance of committing this type 1 error. Generally it is said level of significance are generally kept at the 5% or 1% in case of the social science research. And in case of the Cochrane formula, this level of significance is incorporated into the formula by using the t value. Okay. Like as I already told that for a particular sample size there is corresponding t value for a particular level of significance. Okay. Like if it is 5% level of significance, if you have infinite for this sample size, then t value will be 1.96. Okay. The next part is the estimation of the standard deviation in a population. Standard deviation of what? That is the primary variable of interest. Okay. So, now for calculating standard deviation of the variance of that particular primary variable of interest, okay, so you need to use different formula or you need to use different approach in case of the continuous and the scaled continuous or scaled variable or in case of the categorical variable. Okay. Like if you are measuring the trying to measure the standard deviation of a scale variable, okay, then you have to look into the maximum possible range. You have to look into determine the maximum range, okay, of the scale which are being used for measuring that particular variable. Okay. Like if you are trying to measure the attitude, okay, and it is being measured by an instrument which have 7-point continuum. Okay. So, what is the maximum range possible? That is 7. Okay. So, for calculating the standard deviation, so you have to divide this particular 7 with the maximum standard deviation possible. Okay. Like so, if you using a 7-point scale, okay, 3, 4, 5, 6, 7. Okay. So, this is the mean point, and in this side 3 standard deviation and that side 3 standard deviation. So, total 6. Okay. That will be 7 by 6. Okay, which will come like. Okay, so it will be 7 by 6. Okay, so each side, so that means 3 point possible in both side of that particular scale, this particular 7-point scale. Okay, and now this particular standard deviation or this particular variance that will capture, that will be through the 98% of the sample. Okay, now if it is instead of this continuous or scale data, if it is a categorical variable. So, in case of the categorical variable, okay, instead of standard deviation, if you remember in the formula we use P into Q, okay, this proportion. Okay. So, what is the maximum? It is the maximum variance possible, that is the 0.5. Okay. So, if there is the 50% is the maximum variance possible in case of the categorical data. Okay. Now, if it is 80% or 20%, okay. So, 80% or 20% means the larger majority of the population either do or do not have that particular attribute of the interest. Okay. So, maximum possible range is the 50%. Okay. So, now you take this particular formula how to, and last part is that is the acceptable margin of error. In case of categorical data, it fixed at 5% level. In case of the continuous or scale data, it fixed at the 3% level. Okay. So, the same in the same example. So, I told that this 7-point scale is there. Okay. So, that means what should be the margin of error? Okay, if you calculate it in the 3%, okay, that is 0.3. Okay, that means plus minus 0.21. Okay, that means that the mean calculated from the sample, okay, the true mean will be the plus minus 0.21 of the or population mean will lies in the plus minus 0.21 from the mean calculated by the sample. Okay. So, that is the this acceptable margin of error. Okay. Now, let us try to use this formula to calculate a sample size. So, now you just assume that we are trying to use this particular formula for calculate the sample size. Okay. So, what will be the sample size? Okay. In this particular case means you are using the primary variable of the interest by using a 7-point scale, okay, and there is the 3% is the acceptable margin of error. Okay. So, what is the t value? I already told that it is the for infinite population size it is 1.96. So, it will be the what will be the sample size? N is equal to 1.96 square into that is 7 by 6. Okay. If you calculate divide this 7 by 6. Okay. So, 7-point scale we are using. So, it will come like 1.167. Okay. So, it is whole square divided by d square, that is the margin of error. So, margin of error it is calculated 0.03, 7-point scale you are using. Okay. So, that is the, so that will be the so if you calculate this one. Okay. So, it will give like it will be around 3.84 to 1.167. Okay. So, it will be 1.37 divided by 0.0441. So, if you calculate this one it will give you like 119.29. Okay. So, around you can take it as a 120 also. Okay. Now, so if you use a this particular for the continuous data you will arrive at a sample size of the 120. So, if you remember in the first lecture of this sample size determination I posed a question that in MSc level sometimes we use 120, okay, sometimes in PhD level we use 240, 300, okay, without understanding this that it came from the actual formula. Okay. So, 120 is the approximate sample size. Okay. So, now if you remember the next part. Okay. So, you have to arrive the more precise sample size. So, by using this formula you get an n primary sample of the 120 or if I take it, okay, it will be around 119 also you can use. Okay. The next part what the Cochrane formula is telling. Now, the primarily arrived or primarily determined sample size if it is more than the 5% of the population. So, this scenario came when you know the population size. Okay. So, if it is more than the 5% then you have to use the correction formula. Okay. What is the correction formula? So, here the sample size. So, just you assume that you have a population of the maybe 1679, okay, that is the your population size. Okay. So, what is the 5% of that? Okay. So, it will be 5%, that means you will arrive around the 83 or 84 around, okay, 83.95, 84. But in this case what is our determined sample size, that is 119 or 120. Okay. So, what you need to do? You need to use this correction formula. So, the N0 was 120 by 1 plus 120 divided by your population of the 1679. Now, if you solve this one, okay, it will give you around 112.14. That means 112, that is the more refined sample size by taking into consideration that the next part, that is the determined sample size exceeding the 5% of the population. Okay. So, next part is that if you remember I told that you have to take into consideration other things like missing value, response rate, non-response rate and all these things. Okay. Now, just you assume that maybe in your research you assume that or you know that there will be 80% response rate. Non-response rate should be adjusted for. Okay. So, response rate is 80%. Okay. So, now you have to arrive the more refined part or this non-response rate adjusted sample size. So, what will be that? So, that will be N1, that is the 112 divided by what is the, it is 80% response rate is there. So, 0.80. So, it will be around 140. Okay. That means your sample size are adjusting for the non-response rate. Okay. So, it will be around 140 sample. Okay. So, this second two part is based on the assuming that your population size was 1679, okay, that is a random number. Okay. Now, so I think in this point it is clear. Okay. So, let us try to calculate the sample size for the your categorical variable. Okay. So, t value that remain the same. Okay. So, here if you use this formula, your n0 will come as t value, that is 1.96, okay, that is okay, into it will be, I told that for a categorical data we use the, instead of using the variance of the primary variable in the population, okay, use the estimate of variance in terms of the proportion. Okay. So, it is generally used as, so maximum possible variability is the, I told that it is 0.5. Okay. So, it is the most largest sample size you will get by using this, okay, because okay, actual variance may be lesser than that. Okay. So, now it will be divided by again, so acceptable margin of error. Okay, I told that in case of the categorical data, we generally categorical variable we take it as a 0.5%, okay, 5% level of significance. Okay. So, sorry, 5%, or it will be 0.05, okay. So, that whole square. Okay. So, what will be, if you calculate this one, so you will arrive at, it will be 3.84 into 2.1, okay, 0.25 divided by, it will be 0.05 the whole square, that means it will be around 0.0025. Okay. So, if you calculate this, it will arrive you the 384, that is the sample size. Okay. Now, again if you look for the correction for the, if you look or if you apply the correction formula, because it is again in the same way, 84 was supposed to be the 5%, if you take the 1679 as a population size. So, 80% this 5% of it was supposed to be 84. So, here it is more than that. Okay. So, what we will do, we use this correction formula, we will arrive at a n1, that will be 384 divided by 1 plus 384 by 1679. Okay. So, around it will come like 384 divided by 1. If you solve the denominator part, it will like that. Okay, it will be around 312. Okay. So, now again after this you have to look for the adjust for the other factors, like one of the factor is the response rate. Okay. So, again if you go by the similar way, there will be 80% response rate. Okay. So, we will go by this one. Okay. So, around 390. Okay. So, that will be the your required sample size in case of the categorical data. Okay. 384, and then it come to the, after correcting, 312 and 390. Okay. So, now you can use, I already told that when the population size is known. Okay. So, you can use this particular formula instead of all the Cochrane formula, it is much simpler in form. Okay. Like if you assume that the population size is, maybe it is known, okay, 2000 is the population size. Okay. Let us take it like 2000. So, what will be, n means 2000, okay, into 0.05 whole square. So, if you solve this, it will come from the 333. Okay. Then around you have to again adjust for the whether this sample size, obviously it is more than the 5% of the population, then you have to adjust for that particular part. Also you have to adjust for the your non-response rate or response rate or other biases. Okay. So, now instead of that, I told that one of the ready-made way is that you use the already given table of the KG Morgan. Okay. So, that is the mostly used, sometimes mostly used table for determining the sample size. Now, in the KG Morgan formula, if you look minutely in the table, you will find out for the population size. So, that is more than 10 lakh or up to 10 lakh. Okay. After 75,000 it is 382, and after 75,000 if the population size is 10 lakh. So, your sample size will be 384 will be sufficient, and we arrive that sample size in the using this Cochrane formula also, Cochrane formula for the categorical data, and that is why it is being told that if you after the 10 lakh, if you increase the population size and accordingly if you increase the sample size, it does not give you any more accuracy. Okay. So, that 384 it is taken as the golden number in case of the sample or selecting or golden number of the sample size. Okay. But again, as I already told, you have to keep into the mind that it is for the categorical data, okay, and assume an alpha level of the 5%. Okay. 5% level of significance, that is the base of this particular table. Okay. So, now in the beginning, okay, I told that sample size depends on a number of factors. Okay. So, here we only determine the sample size based on the margin, the error margin, based on the level of significance, based on the variability in the distribution of a particular dependent variable or the primary variable of primary interest in the population and all those things. Okay. So, apart from that, there are also certain other factors that may be useful for determining the sample size. Okay. So, one thing, okay, I should tell here that there is no one size fit all solution to address this sample size issue. Okay. So, it may depend on the nature of research or the statistical analysis also. Like if your research it involve complex model which may have a numerous number of variables. Okay. So, it required the larger data set. Okay. So, models which may have the moderator variable, okay, or multiple groups, that also require the larger sample size. Okay. Like if you are using exploratory factor analysis, okay, so less than 50 sample or it cannot be used. Okay. So, if there is enough 50 less than 50 observation. Okay. So, if you are using simple regression analysis, okay, so the researchers suggest that 100 sample, okay, is sufficient. Okay. So, if you are using correlation analysis, so you must have at least 200 sample, minimum is the 200. Okay. So, these values actually varies little bit based on the different opinion of the different researcher. Okay. So, also the sample size may be affected by your research supervisor or as well as the practical consideration. Okay. So, how much he want to accept, how much error or how much precision, okay, he is agrees to accept, that is the important thing. Okay. So, a large sample size can make any relationship statistically significant. So, I already told that in the beginning. Okay. So, because of that, okay, sometimes you will find out the researcher, okay, they sometime coincidentally achieve the higher significant result. Most of the cases you will find out, okay, in the social science research they are reporting the highly significant. Okay. But if you look into the effect size, you will find out the minimal or the effect size is very less. Okay. So, it is because of this use of the very large sample sometimes. Okay. So, also the researcher should consider, okay, that how much percentage of the respondent he want to reach, okay, how much percentage of the respondent want to participate in his survey, okay, and how much percentage, okay, how much will be the response and non-response rate. Okay. So, that will be also the criteria for the sample size determination. Okay. So, there are a number of thumbs or rule of thumbs, okay, which may be used as a ready-made guide, okay, for the sample size determination. Okay. But again I will suggest that the use of the statistical formula is the best way. Okay. So, and if you know the population size, then it is not a problem, but most of the cases, okay, in case of the social scientific research, often you do not have any understanding of the population size, then you have to go by the golden rule or the formulas. Okay. But there are certain other process also which can be, or there are other certain rules also which can be used for the determination of the sample size. Okay. So, one of the such rule is the sample to item ratio. Okay. So, this sample to item ratio often used in case of the factor analysis. Okay. So, the ratio should not be less than 5:1. Okay. So, like if you have in your dependent variable may be using a knowledge test. Okay. So, there are 30 items. Okay. So, that means there should be at least 150 respondent. Okay. Also some researcher also suggested that instead of 5:1 you use because 5:1 sometimes it is not sufficient, okay, or leads to the underpowered study. Okay. So, that is why instead of that you use the 20:1. Okay. So, as I told, it is mostly used for the exploratory factor analysis. Now, another rule of thumb is that use of the sample to variable ratio. Okay. So, mostly you have a number of independent variable or 2, 3, 4 or limited number of dependent variable as a part of your research. Okay. So, in case of the use the sample to variable ratio as a sample size determination tool. Okay. So, minimum recommendation is that use the 5:1. If there is 10 variable, then sample size should be at least 50. Okay. Also, many researchers suggested use of the higher ratio. Okay. That is the 15:1, 20:1, okay, that is more preferred. Okay. Because okay, many particular researchers they disagrees that 5:1 okay, is not sufficient, okay, for especially for the when you are using the regression analysis, because most of the social scientific research they mostly use this particular regression analysis, correlation analysis. Okay. So, this 5:1 study as I already, or 5:1 ratio level as I already told, it leads to the underpowered study. Okay. Now, I already explained the use of the Kaji-Morgan table. Okay. So, instead of using Cochrane formula and all those things, you can use the Kaji-Morgan table to as a ready-made guide for the sample size determination. And it suggests that if more than 10 lakh population is there, then 384 is the sufficient number. Okay. That is why it is being called the magic number in the research, 384, magic number in the sample size determination. Okay. But this KMT, in case of the social scientific research, KMT can be used or should be used to determine sample size when you are using probability sampling. Okay. That means simple random systematic stratified sampling you are using. Okay. And the variable, the primary variable of interest is in the categorical level. Okay. So, there are also Roscoe's guideline. Okay. So, Roscoe suggested that the sample size greater than 30 and less than 500 is suitable for the most of the behavioral research. Okay. So, if you increase the sample size beyond the 500, then it will result into the type 2 error, okay, or higher type 2 error. Okay. So, if you remember this type 1 and type 2 error, they have the inverse relationship. Okay. So, more type 2 error, okay. So, it generally decreases the type 1 error, or if you decrease the type 1 error, it increases the type 2 error. Okay. So, you have to look into that aspect also. Okay. So, Roscoe's guideline, Roscoe is also telling that for comparative analysis, okay, so if the data set needs to be broken into several subgroups, okay, so like male, female, rural, urban, local, international, okay, so you have a number of attribute variable. Okay. So, this 30 respondent is considered bare minimum for the each group. Okay. So, that means if you have two group, then you must have the 60. Okay. So, that is the minimum sample size. Okay. And in case of the multivariate data analysis, like you are using the regression analysis, okay, so the sample size must be 10 times greater than the number of variables. Okay, that was also proposed by the Roscoe in 1975. Okay. So, there are also this rule of thumbs, okay, which was proposed by Green in 1991 in his research. Okay. He proposed that the sample size should be greater than 50 plus 8 m. Okay. So, m is basically number of predictors in the model. Okay. So, like if you are using the coefficient of determination, you have a number of independent variable, maybe the 5. Okay. So, your sample size for the in that cases, okay, so if you have the 10 predictor, okay, so it will be 50 plus 80, okay, 130. Okay. So, that is the minimum sample size. Okay. So, also this Green procedure is also talking about that if there are independent predictors, okay, so instead of that you can use the sample size which is greater than the 104 plus m. Okay. So, but this particular rules assume that the medium size relationship, okay, there is medium size relationship between the independent and dependent variable, okay, and the alpha is at, that means type 1 error in the 0.05% type of level of significance, and the beta, okay, that is the type 2 error. Okay. So, that is the at the 20%. Okay. So, that means 80% power of the test is there. Okay. The most suitable way, or most apart from the using the Cochrane formula, another way to calculate the sample size is using the power analysis. Okay. For the power analysis, okay, so power analysis determine the sample size by taking into account the part of the model with the largest number of the predictor. Okay. So, for using the power analysis, you use the information regarding effect size, you need the information about significance level, okay, to calculate the minimum sample size. Okay. So, like I already told, okay, so this alpha, this level of beta, okay, so these things are very important, okay, that to use the power analysis for determining the sample size. Okay. So, as a general rule, okay, Cohen suggested that the value of 0.02, 0.15 and 0.35 interpreted as the small, medium and large effect respectively in case of the what effect, okay, that is also the requirement. Okay. So, you need the significance level, you need the power, you need the effect size. Okay. So, that is the for using the power analysis, and There are a number of software also available, okay, like G power is there, SS is there, SPSS is there, okay, solar power analysis is there, PASS, that is analysis and sample size system, okay. So that can be used for the power analysis, okay. Like G power is mostly used for the calculating the power analysis. It is an, you can go to the this console of the G power, and as I already told, okay, that you can fix the beta level, this power of the test, you can fix the what the level of significance you want, okay. You can fix the effect size, okay, you want for the study like 0.02, 0.15, 0.35, okay, and then you can put all those values there, and you can come out with an suitable size. You have to give the population size, then you can come out with an suitable sample size by using this particular software, okay. So in this class we looked into that how to use the Cochrane formula for calculating sample size in case of your continuous data, in case of your categorical variable, okay, and how to use those different parts, okay. Also we looked into the KGD Morgan table again, okay. The 384 is the known as the magic number, but with the limitation that KGD Morgan table is useful for the categorical data mostly, and it assumes the 5% level of significance, okay. So also we looked into a number of rule of thumbs, which can be like sample to item ratio, sample to variable ratio, okay. So all these rule of thumbs or different statistical technique, what is the minimum advisable sample size, okay, for the determining the sample size for your research. I think by now it is clear to you that how to determine the sample size, whether 120 is the perfect sample size for your research or not, and what should be your sample size when the population is value is known, after taking into consideration this non-response rate, after taking into consideration the 5 this Cochrane guideline of the 5 not exceeding the sample of the 5% of the population. With this we will end our today's lecture. For further reading you can go through these books, and this one important one article is there, which is I already mentioned the link here, okay. So to clear your idea about the sample size determination. Thank you.